Okay, the number 3 of this particular JAMB mock. Now remember that the arrangement of these numbers is based on the way I just picked the question from the students, not the way it appeared in the workplace. So let's solve. Now we have a man walks 20 meters due north, 60 meters due east, then 80 meters due south. How far is he from the starting point? Now how far is he from the starting point? Let's carry on. Now let's start. When we say I hear a question on starting point, your mind should be on what? On displacement. Displacement is a continuous change in what? In direction. So I've mentioned sometimes what we usually use and note displacement is that first you have someone starting from here, move, maybe enters here. Then for you to get from this here to the end point, you just have a line like this. From here to here is always your what? Displacement. Now, first thing you have to have in mind is that you will always have two directions. Most of the times, you have your y and you have your x direction. When it comes to displacement, we are solving displacement. But in this particular question, you are seeing three directions: north, east, and what? South. How can we solve a question like this? If you have a question like this, how can we solve it? First, your cardinal points will help you first. That's the first thing. So you draw your 4 cardinal points so you can note the direction. This is your north, and this is your east, this is your west, and finally this is your what? Your south. Now note that the man walked 20 meters due north, so that means he walked towards the side. Then after that, that is 20 meters. Then after that, he now walked 60 meters due east. So he walked 60 meters due east. Then after walking 60 meters due east, then he now walked 8 meters due south. 8 meters due south. So at the end of the day, if we bring out this diagram, so the diagram will look like this. Finally like this. So this is 20 meters, this is 60 meters, and finally this is what? 8 meters. So if you have a question as in something like this, so first thing to do is that we will now say, okay, that first we have to resolve this so we can have two what directions, so it's kind of easier for us to do this thing. So first, this direction and this direction, they are opposite to each other, so we can resolve it first. This direction does not have another counter opposite distance, so we are only resolving these ones that have almost different direction, but they are opposite to each other. So if we bring this direction together, which is your north, and I'll bring another one which is your what? Your south. Here is your 20 meter, and here is your 8 meter. Now, if you look at our normal typical graph, we'll have something like this. We have our y-axis, we have our y-axis, we have our x, we have our x. Well, here is our positive x, here is our negative x, here is our positive y, and here is our negative y. So anything that falls in around here is our positive y. Anything that falls in around here is our positive x. Anything that falls in around here is our negative x. And anything that falls in around here is our negative y. So now let's carry on. Okay, I wanted to check whether the video is recording. So now we have our positive x and we have our negative x. Then this is our positive x and negative x. Now if we have something like this, now if you check what we have here, we have 20 meters like this towards north. That means it was found around here. And we have our 8 meter around here. So that means our 8 meter will carry what? Negative 8. Remember what I explained here. So now if they are in the same vertical axis, so this is our referring vertical axis, we are going to add them. You understand now? So we can make them one. These ones, they are not in the same side. These ones are horizontal axis, so then we can't add these ones. So we can only add this, the one that is in the same vertical axis. So let's add the vertical axis. This is on topic on vectors. You understand? Topic on vectors. I think I'm going to draw videos on vectors so I can explain this thing very, very well. So what is going to happen is that have a 20 meter plus bracket minus 8 meter. Remember why it is minus 8, because it's found in the negative y. So it will now be 20 meter plus times minus, that's minus 8 meter is equals to 12 meter. Did you see it now? So if we have this, it is 20 meter minus 8 meter is equals to what? 12 meter. If I have something like this is what it's going to now be. It's now going to now be that that means that if I resolve this thing will be like this. But it's positive 12 meter, that means it's towards north. So that means this is going to be 12 meter. And if I add this one, it's now going to be what? 60 meter east. So I've gotten to direction now. 12 meter and 60 meter. So what's the next thing to do? Find your displacement. Remember, that's what the question is actually asking you from the starting point. Now, find from here to the starting point. Look at the starting point here. That's what we want to now find. Now, if I want to solve this now, this is forming a right angle triangle. You can see that. It's forming a right angle triangle. Here is my A, here is my B, and here is finally my what? My C. So if I have something like this now I have that. My A here is what? Displacement. Here is my B, and here is my C. So what is my A? My A is unknown. What is my B? My B is 12 meter. What is my C? My C is 60 meter. So having something like that, I want to have that A squared is equal to B squared plus C squared. What is my A squared? Unknown. So this formula is from Pythagoras theorem. Our B is what? Is 12 squared plus 60 squared. So if I have that now, the A squared is equal to square root of 12 squared plus 60 squared. Because I've actually removed the squared and put it as square root. So my A is equal to 12 squared is 144 plus 60 squared is 3600. 60 times 60, 6 times 6, that's 36, 0 times 6, that's 3600. Now if I add these two together, it should be giving me, let's add, 4, 7, 3, 7, 4. So A is equal to brackets and the square root of 3, 7, 4, 4. That's what is going to. Now remember that the question was left in what? Left in solved. So this is left in solved. So if I want to get this in solved, remember that solved has to do with you get one of them that is perfect square and get the one that is not perfect square. So you remember how to know it, that first you have something like this. All your perfect squares you have from 1 to, you have to know your perfect squares at least from 1 to 15. The perfect square of 1 is 1. Perfect square of 2 is what? Is 4. That's 2 times 2, 4. Now, after that, 9, etc. You understand? So if I have something like this is 3,7444. Now, the major thing that have to come to my mind is bigger numbers. So I'll start asking myself that which of these numbers can I divide by any of these to give me, that it will not have any what division. It will going to give me what is it called? Okay, let me give an example. We have 16, we have this. So let me find a number, then I'll explain to you how I got it. So I use this number now to start dividing by some perfect squares. This is 1, 4, 9, 16. Anyone that not give me any decimal, that means that particular number can actually work on this. And one of the one I used in solving it, in dividing, was 144. So when I divided with 144, I got 26. Yes, I got 26. So that means that this A will now be, what this thing means is that it will now be 144 times 26 will give me this. That's what it means. So I will split this into 2. So now the square root of 144 times square root of 26. It's just the same thing, but I just split it into 2. Will give me 3,744. So what is going to do? What is the square root of 144? That is 12. That means that A is equal to 12 root 26. That's what it's going to be. So that is what the starting point is. So remember that it's measured in meters. So my answer will be in meter. But if this thing was not actually in salt, we'll measure the JAMB will always test you on salt. We just divide A is equal to 3,744 divided by, now square root of this. That's going to be your answer. So this A is your starting point. Now let's go to number 4 question. Now let's take number 4 question. You see an EMF of 2.6 volts, an internal resistance of 0.2 ohms is connected to a 3.5 ohms resistor. What is the current in the circuit? Now, first thing you have to have in mind is that this is actually dealing with a battery. You understand? So this is actually dealing with a battery. You know that majorly the battery, the voltage inside the battery before it's used is called what? EMF. And the battery itself has chemicals itself and plates. The plates inside battery acts as a resistance. You understand now? So it's not all the EMF. You see, EMF is something like 3.5 volts. That means you're not going to use all of them because there are some plates that will still resist the current that is flowing from that battery out. Now, the place you connect the battery also has its own resistance. You understand now? So you have 2 resistance now, one from inside the battery and one from outside the battery. One from inside the battery, we call it internal resistance. And how that's R, small r, is equal to internal resistance. Now, the one from the external circuit is one we just call the normal resistance, which is just this thing. So just have that one as big R as normal resistance. Now, if you want to calculate EMF of a battery, you can remember that your V is equal to IR, right? But now the V we are dealing with here is EMF. That means that EMF is actually like this one is the one found in the battery, the voltage found in the battery. When the battery is not in use, that's electromagnetic force. Now we have that V is equal to IR. So and now the IR we have here now is for internal and what external. So it's now going to be E is equal to for internal, we are going to have internal and what external. So we have our IR small r plus our V IR. You get that now. Our E is equal to our I small r plus our V IR. So what is common here? I is common here and I is common here. So if you pick the one that is common, then it's now going to be what? I R plus big R. I factorize the R here since they are common here. So you have a formula like this. So this is the formula for solving what? EMF. Now let's go to the question. So the question says they have actually given us the EMF. So and what we are looking for is the current. So let's make the current into the formula. If you want to make current into the formula, what will you do? Divide both sides by what? R plus this thing. So that you can cancel out this is the one you wanted to stand alone. So you cancel this and cancel out this. So your formula now becomes I is equal to E all over R plus big R. That's what we have. So let's use this now and solve. If we have something like this, it will now be our current. It's now going to be, what is our EMF? 2.6 all over, what is our this thing? That's going to be 0.2 plus 3.5. If I add these two together, my I will now be 2.6. That's going to be 3.7. My I will now be equal to so my answer will now be 0.7 watts of 70 amperes. That will be my answer. That's going to be my I. So hope you understand this and hope you're enjoying the video so far. And don't forget to click that like button and share it with your friends. Share those ones that is writing JAMB. Share with them so that these particular videos will help them. Thank you very much. And let's head over to the next question.
So let's take the next question here. We have an object projected horizontally from a height 50 cm reaches the ground in how many seconds? So this particular question is connecting to two topics. That's projectile motion and equations of motion. And that's what this particular question is. So now, the first thing you have to note now is that you have to have it in mind that this projectile was horizontally. There's one thing I want you to understand, that object thrown horizontally and object thrown vertically. Do you understand now? All of them will arrive at the same time. So all of them will arrive at the same time. So objects projected horizontally and objects projected vertically. Projected horizontally is shown like this. Projected this lift from a vertical height is like this. So all of them will arrive at the same time. So that's one of the things I want you to understand. So this should not actually confuse you. Now let's look at this thing. So this particular thing now was projected from a height 50 cm. The major things we are looking at is the vertical distance. And now they remember, okay, there was a place to say use G as 10 meters per second square. So there we say this thing there. So to have a question like this, the solution now is for us to find a time. Now if we look at our projectile, we have time to reach a maximum height and time to reach time of flight. But the question here now is of a vertical height. So we are not going to use a projectile formula. We're going to use a vertical height because the height is vertical. So that means we are looking at the major things we'll be looking at is equations of what? Motion. So now having that, we now have that our initial velocity as initial distance here, when it was left from a height, that means it was actually held like this. It was held like this before being released. So that means our initial velocity, which is going to be y, is going to be 0 meter per second. Why is it 0 meter per second? You are holding it. When it was holding it, remember initial velocity was the velocity it is before it now changed. So it was holding, they were holding it before they now released it. But they were holding it that first time it was holding that 0. The next velocity will now be when it is now released going down. So that is for that particular one. So the next thing is the height system, which is 50 cm, which is h is equal to 50 cm. Remember that this is in cm. That means that this particular thing was not meant to, this is meant to be converted. So for you to convert this, there are some simple tricks you have to have in mind. If you're converting anything to meter, it can be in 3 senses. It can be in millimeter, it can be in centimeter, and it can be in decimeter. Do you understand that? It can also be in kilometer. So if you want to convert from a millimeter, there's one thing I want you to understand. Milli is 1,000, remember, right? So it's going to be 1 over 1,000. So anywhere you see milli, you replace it to 1 over 1,000. Then cent is 100, which means that anywhere you see cent, you replace it to what? 1 over 100. deci is 10, 1/10 kilo is 1000. So you don't put any distance, so it will not be anywhere you see kilo because it's 1000 meter. So let me give you an example. If I have 2 millimeter, it's now be 2 times 1/1000 meter. So anyway, it's now be 2/1000. If you divide it, that's 0.002 meter. Have you seen what I did? That is how to do it. So if I apply that distance here, if I apply it here, because this is in centimeters, so I have to convert it to now the H is going to be 50 times 1/100, and so H will now be equal to 50/100, which is going to become give you H is equal to 0.5. But this is 0.0, we have the other one. So that is what our H is. So having this, we will now find a formula that connects H, C, and also acceleration due to gravity, but they gave it to us in the equation solution. And the formula, the equation solution, remember there are 3. We have our V is equal to U plus AC. We have our V squared is equal to U squared plus 2AS. We have our S is equal to UT plus half GT squared. So we know this one, the one that connected height, this is having S, which is our height here. This is having time, and this is having acceleration to gravity. This is also having this. It's also having, but it's not having time, so we can use it. Now this is also having this, and what again? Okay, so but it's not having H. So have you seen now? The only one that have the O is this last one. So having this, we can now use this last one. Let me check my video. Okay. So have this. That our S is now going to be equal to UC plus half GT squared. Remember that my U is what? 0. My U is 0. So remember why it's meant to be here. It's now the S is equal to 0 times T plus half G times what? What is our time? Our time here. Was it 0? That's what we're looking for. Yes. And our this thing now is 10. This half will cancel out 10. You have what? 5 remaining. 0 times T is 0. You have, which is 0.5. So 0.5 is equals to half times divided by 3. I'm eventually getting 5. So you now have 0 plus 5t squared. 0.5 is now going to, if you add these two things, you have 5t squared. So what are you going to do? You divide both sides by 5. If you divide both sides by 5, it should give you divided by 2. So we'll have 0.5 divided by 5 plus 0.5. So we'll now have I get this. Now you now have 0.1 is equal to what? T squared. So which means that T is equal to square root of 0.1. So what is the square root of 0.1? That is going to give us 0.331 seconds. That's what I will do. Thank you very much, and see you in the next video.